So good morning to all. So today we have to discuss about that. There are different types of transistor characteristics. Okay, the last class already discussed about that. What is the transistor function? What is the how to work from the transistor? What are the advantages of transistor? What are the disadvantages of transistor? Already discussed about that last class. Okay, already discussed. So today how to discuss about that. What are the different configuration it will be used for the transistor side? What are the different configurations? Okay, so normally there are three types of configuration it's available. First one, it can be used from the common base configuration. That is very important, common base configuration. And second one is common emitter configurations. And third one is common collector configuration. These are from the very important configuration today I have to discuss. So what is the configuration? This is different types of characteristics. Different types of characteristics we have studied today how to discuss. What are the characteristics? Especially, you can go for what is the input, what is the input impedance, what is the output impedance, how to calculate from the voltage and current gain, and what is the input current, what is the output current, leakage current, that is input and output applied between the emitter base and collector base. These are from the several discussion about that in this topic. Okay, so transistor characteristics is nothing but there are different parameters. These are from the different parameters today I have to discuss. Especially you can go for input impedance, input resistance, as well as from the output resistance, and then input current and output current, and what is maybe leakage current and current gain and voltage gain and different types of applications. Well, why it is used for transistor means the transistor is the stability gain is very good comparatively for diode and discrete components. It will be used from the, especially it can be used from the diode, resistor, and capacitor. It will be used that n number of component it will be used. So definitely it will be some losses. It will be there. The current movement direction, the current direction it will be delay from it. The minute level it will delay. So there is from the several disadvantage from that discrete component, especially can used for diode, transistor, whatever it is, capacitors and inductance and whatever it is, everything. Yeah, suppose we have to use to for that is called simple transistor, simple adapter connections means it can be used for discrete component can be used, but n number of component can be used means there are several voltage we some need, some current will need. So these are from the some disconnection connection problem is there. N number of connections definitely will be more connection problem it will be there, and one n number of wiring it will be there. So you should be avoided. It can be used for directly. It will be used for transistor. Okay, transistor is nothing but is the gain. It will be very good compared to for discrete components. Okay, gain as well as from the stability factor. That is very important. Stability factor means that is called from the S. S is equal 1 plus beta. 1 plus beta is that will be current amplification factor. These are from the several advantage it can be used from the transistor also. Okay, that mainly can why it is used for transistor. The stability has to be very good. The current gain has to be very high comparatively for discrete components. Okay, so today I have to discuss about that how to work in that different configuration. What is different configuration? It will do for common base and common emitter and common collector also. Okay, you have to compare these three things. Very good configuration, I think, but it can be it is useful from the common emitter configurations. Okay, because the stability has to be very good comparatively for common base as well as from the common collector, because a number of stage of amplifier is available. A number of stage and amplifier is can be used. The frequency normally the frequency is to be very good. These are from the several advantage from that common emitter configuration. Normally, mono configuration you can check that. Normally, it can be used for the three configuration. You can check. It means normally you can use for very good configuration that is called from the common emitter configuration. Okay. So first we have to discuss about that. What is the function of the transistor? Okay. There are three types of configurations available. First one is it can be go for common base, common emitter, and common transistor, common collector. Okay. So the base emitter junctions normally already know that the base emitter junction always forward bias. Okay, already last class discussed about that. What is the two function is there? Is normally whatever it is any transistor, the common whatever any transistor can be used to NPN transistor as well as on the PNP transistor. The emitter base junction, the base emitter junction is always from the forward bias. That is very important. Always from the forward bias, while it will be used for the collector base junction is reverse bias. In this condition, it can be satisfied. The operating transistor is the active region. Active. Otherwise, there should not be act. Transistor, how it will work? The emitter base junction is forward bias. The reverse bias, it will work from the collector base junction is reverse bias. In this condition, it can work. The transistor to be satisfied. Suppose we have to check the diagram. So this is the base. So the emitter is negative. Yeah, normally emitter is becoming negative. The base is positive. So the emitter base junction is forward bias, and then collector is this is called base is come to negative. The collector is becoming positive. So reverse bias. Whatever it is, any transistor, the emitter base junction is forward bias and the collector base junction is reverse bias. The same thing it will be of PNP transistor. What is the B? Is the emitter. Emitter should be positive. The negative should be connected to base. And whatever the base, it should be connected negative, and the base should be positive, the collector should be negative. So in this condition, so it can be acted by the reverse bias. Okay, whatever it is, PNP transistor, whatever NPN transistor, the base emitter junction is forward bias, and collector base junction is reverse bias. Okay. So what is the first one is we can discuss about the common base configuration. Okay, so the complete from the electrical behavior circuit, it is necessary to study about that interrelation the various current and voltage. Why it is used for transistor we can study. We can study about that various current as well as from the voltage we can discuss. This relationship can be plotted graphically, commonly known as characteristics of transistor. What is in the characteristics of transistor? We can study about the various current as well as from the voltage. That should be relationship. That is called as characteristics of transistor. Characteristics of transistor, we can study about the various current as well as from the voltage from the relationship in the plotted graph. This is called as characteristics of the transistor. Okay. So next one, the most important characteristics of configuration are input and output. Normally, whatever it is, any characteristics, as any configuration, it will be like that, common base, common emitter, common collector, whatever it is, any characteristic, it will be very important characteristics as well as from the input as well as from the output characteristic. What is in by input? Input is, it can be dominant input to the input side. Okay, you can vary the input voltage, it can be vary corresponding, it will be noted for the output voltage. Okay, that is all the characteristics of the input and output characteristic. Only you can change input level and corresponding it will be noted for the output level. That is called from the input. Input that should not be vary, input that should not be constant. Input it should be vary level and corresponding noted from the output of the level. These are configurations that is called from the voltage and current. It should be calculated. Okay, that is called from the input and output characteristics of any configurations. And this next one, the basic configuration of common base, it can be applied into that. The input is applied into the emitter base and output is taken by the normally whatever it is. Emitter base junction is, we can two sources we can apply. First one is we can apply, this is input of this side. This is input outside, this is output of the side. What is the input of the side? You can use it for emitter base junction. You can use it for VE, that is called VE, that is called from the input of the side, and VCC, that is called from the output of the side. Okay, whatever it is, any configuration can be used for common base and common whatever it is. The input of side you can use it for, this is of the input, this one output, right? The left hand side can be used for input of side, right hand side. What is emitter base junction? That is called input, and collector base junction as covered in output of this side, and both as well as from NPN as well as from the PNP. So what is the first condition? So what is first condition? Emitter base junction is forward bias and collector base junction is reverse bias. We can study it into that. There are two configurations like that. The common that you can study about that input characteristics as well as from the current output of the characteristics, and then we can calculate measuring the various measuring the current or voltage. We can calculate. These are from this several. These are from the input and output characteristics of the NPN as well as from the PNP transistor. And next question for what is the relationship between the configuration? Normally, the common base configuration is the collector current. And the current should be measured. So three current will be available. First one is base current, that is called IB. Next one is IE, that is called emitter current, and IC, that is called from the collector current. Okay, I is rotation is, that is called from the current. Okay, current it should be measured. What is the collector current? That is called from the IC. Emitter current, that is called from the IE, and base current, that is called from the IB. Okay, so what is the condition? So these are from the IC is equal IC injection plus IC base. What is IC? What is collector current? Collector current is nothing but IC injection plus ICBO. That is called from the IC. IC injection plus ICBO. What is IC injection? The IC injection is nothing but the collector current. What is the collector current due to emitter to the number of electron crossing into the collector by junction? What is the IC injection? The collector current, the n number of electron, the collector current, current now you can electrons be there. So n number of electron crossing into the collector by junction. Okay, collector by junction is output of this side. Okay, not for the emitter by junction is input of this side. The collector by junction is from the output. N number of current, it will be crossing the junction. What is the cross the junction? The collector by junction. That is called from the IC. That is called injection. That is the collector current. And nice ICBO, that is called from the leakage current. That is called from the leakage current. ICBO is nothing but is a leakage, common base output of the one. Okay. So if the reverse saturation current, following the minority carrier between the collector and base current, it will be open. Okay. So that is called IGBO is negligible compared to the IG. So finally, you can IC is equal. ICBO is nothing but is a leakage current. Okay, that is called leakage current. So what is the leakage current? The reverse saturation current flowing to the minority carrier. What is the minority carrier? It will be go for NPN now, that is called from the P. PNP now, that is called from the P. Okay, NPN is nothing but P is a minority carrier. PNP la N is minority carrier. The minority carrier from the collector and base when it is emitter is open. Okay, emitter is open now is the n number of electron, it can be come into the ground also. Okay, that is called from the ICBO. ICBO is nothing but is a only we can go for collector. The IC is equal, IC injection is okay. And ICBO is negligible. So that is called from the comparable. So finally goes to for IC is equal ICBO. What is by IC? IC is equal ICBO. O is nothing but that is called from the emitter is open. Okay, O is nothing but emitter is open and collector base junction is leakage current. Okay, that is called from the ICBO. What is in the ICBO? ICBO is nothing but ICB is nothing but that is called from the collector base leakage current, and O is nothing but emitter is open. Normally three categories there: emitter, base, collector is there. The O is nothing but it will be considered by the O, that is called by the emitter is open, and ICB is nothing but collector base. This is the circuit of the how to open the circuit. Okay, so first of all, this is the closing the circuit. Base and emitter is the closing the circuit. IC is equal definitely ICBO. So this is also open circuit. So open circuit is definitely be some negligible like that. So this is also negligible. Only it will be go for IC is equal. And this is a closed circuit. IC is equal IC. That is called from the IC. O is nothing but emitter open. This emitter is open, and CB is nothing but that is called from the collector base leakage current. And next goes to for application, current amplification factor. That is very important. Why it is used for transistor? It can be current amplification factor. Another one is voltage amplification factor. Okay, what are the current amplification factor? That is called from the alpha DC. You can measuring the easily rotation by alpha DC. It is defined as the ratio of the collector current resulting from carry injection to the total emitter current. So total emitter current order, you can injection current, final resulting of the injection current. Okay, so what is the ratio? The ratio of the collector current resulting from carry injection to the total. So finally you can know the formula. IC injection is, you know the formula, IC injection divided by IE. What is IE? That is called from the emitter current. So what is the current? So IC is equal, already injection is know that. What is IC? You know that. That is called IC is equal alpha DC into I. So alpha DC into IE plus IC. Okay. What is the IC? IC is you can multiply this one IE into alpha DC plus ICBO. Okay, the ICBO is nothing but is a small negligible value. So finally goes to for IC is equal alpha DC into IC. So alpha DC is equal IC divided by IE. This is the current amplification factor. Because normally very important formula is equal IC is equal alpha DC into IE. That is a IC current. What is the collector current? Collector current is equal IC is equal, that is called from the alpha DC into IE. Alpha DC is IE, and current amplification factor, that is called CB. CB is equal alpha DC is equal IC divided by IE. What is IC? IC is the collector current divided by emitter current. That is called from the alpha DC. So you know the formula. This is standard formula from the IE current. What is the IE current formula? IB plus IC. That is a formula. This is very, very important formula. What is the standard value? IE, whatever it is, emitter current, total emitter current is equal IC plus IB. You know from the IC value. What is IC value? Already can calculate. IC is equal alpha DC into IE. that is called from the alpha current. So we can substitute the value. IB is come to this side, IE minus IC. IE is equal IE minus alpha DC plus ICB. All you can calculate. Also, this ICB you can calculate. You can substitute one. So what is the IE is equal alpha. The ICB already is negligible. It's a small value. Small leakage current will be there. So that is the negligible. What is O? O is nothing but emitter is open. CB is nothing but common base current. Okay. So emitter is open, common base leakage current. CB is nothing but small leakage current is available. O is nothing but open circuit. So that it will be this will negligible. So ICBO is negligible. So finally you can IE is equal 5B is equal I minus IC. What is IC alpha DC into IE? So finally we can substitute the value IE into minus alpha CE. So for IE is you can commonly you can take it for outside. That is called what is the base current? 1 minus alpha DC into IE. Okay. So IB current, first we can, what is the IC current? What is IC current? So IC current is equal alpha DC into IE plus ICBO. That is called from the alpha current. What is IE current? IE current is equal IB plus IC, and totally IB is equal 1 minus alpha DC into IE. Okay. So three values can calculate. First one is collector current, and next one is emitter current, and finally it will go for that is called from the base current. Okay. So this is from the we can measure different parameters should be calculated. Okay, that is the I current. Current is very important. IB current, IC current, as well as from the IE current also. And next goes to for characteristics. Output characteristic. There are already two characteristics available: input characteristics as well as from the output characteristics. Emitter base voltage as well as from the emitter base current. Okay, input characteristics now you can calculate emitter base voltage emitter input. What is the input of emitter base current as well as from the voltage? Okay, what is the output of this side? It will be as well as from voltage. What is the in this curve between input voltage, that is called input voltage, that is called VE, that is called emitter base voltage. Input current, that is called emitter current. Constant collector base voltage at TB. Okay, so it can be very input as of this side, collector as basis constant. We can opposite side. X-axis voltage along this y-axis. Okay, so the emitter current called from the y-axis, emitter base voltage, x-axis. Okay, so what just we have what is input characteristic? Input characteristic just we have measuring input to the input side, not outside. Input side you can calculate. Okay, so input side is common. You can use emitter base voltage is common. This is how to vary, and constant output side. What is collector base voltage is constant. Okay, that should not vary at all. Okay, so first of all, what is the vary? So gradually you can increasing the current. Gradually into the, this is also base voltage. What is the base voltage? Approximately you can go for 1 volt. The different volt you can calculate 1 volt, 1.5, 2 volt. That's not a problem at all. So we can suppose we have to choose for 1 volt. So 1 volt you can cross the junction, immediately current into the rise also. Okay, that is called from the base current. Current on the rise out, voltage gradually increase. Gradually current will be suddenly. That is called from the IE. That's the first we can 10 volt. Next goes to for 5 volt we can apply. Whatever any volt we can apply. So VCB is equal 5 volt. This is. So next we have to go for 1.5. Next goes to 1. So several voltage it can be changed. Voltage it can be changed. Corresponding it will be changed from the base current will be changed. Okay, base voltage change over corresponding will be changed from the base current also. So this is the first experiment from the input of this side. Okay, in this difference, okay, we can calculate from this is that is called from the del E, that is called from the IE current. Okay, we should calculate IE current as well as from the IC current as well as from the IB current. Normally you can go to IE current. This is the emitter voltage. This is the emitter current will be calculated. So difference between these one. So difference between this and this, that is called from the del V. So there are two values here, del IE as well as from the del V. Okay, V is nothing but is a emitter base voltage and emitter current also. Okay, this is also collector base voltage, and this one emitter base, this one is collector base. The input of this that is called from the emitter base, the output side will go for collector base. Okay, so this is the first characteristic. What is the first characteristics of input of configuration? That is called common base. Common base is nothing but you can, this is horizontal side, that is called emitter base junction. The collector will go for collector base junctions. Okay, suddenly this is of the current. This is of the current. So next goes to for output of characteristics. The output of characteristic, it can be go for collector base voltage as well as from the collector's current. Okay, so the input side you can go for emitter base, output side is a collector base. Okay, what is the collector base? There are collector base is very important because we have to, there are different saturation, different levels we can mention it. Okay, first of all, you can cutoff region, second one is saturation region, third one is active region. There are three regions available, whatever any output characteristic, especially you can go for common emitter and common base and common collector, whatever it is, any characteristics. There are three regions very, very important. First one is it will be acted by the active region, saturation region, and cutoff region. Okay, so first of all, what is the how to be act? So first of all, you go the curve between the collector current. The collector current we can measuring, adjusting for the and collector base voltage, VCB, and constant emitter current. The input side is constant. The previous input side, output side is constant, input should be, that is called from the input characteristics. The output characteristics, what is the measuring? Input side is constant, only it can be vary from the output side. Okay, so what is the output current? The collector current, it will be nothing but IC, and collector base voltage, it can be vary, and constant will be I is constant. That is called from the output of the side. So finally, the collector current is taken along the y axis, and collector base voltage is the y axis. Normally, collector current is y axis, and x axis is the collector base voltage. Okay, so how it will be plotted? So first you can check that. Okay, what is the voltage? So what is the input of this? What is the output of this? The collector current. What is the emitter current is constant. What is emitter current? The emitter current became a constant. Emitter current is I is constant, rapidly it increases. What is the value? So you can change the value. This is first emitter current. This is second emitter current, and third emitter current, and fourth emitter current. This is active in this region. In this region, that is called from the cutoff region. Okay, what is the cutoff region? So you have to increasing the VCB, that is called from the collector base, and suddenly you can constantly collector current will be travel, because constantly we can collector current travel, that is called from the I is equal 0. Next goes to for 1 we can apply, that is called from the 1 ampere, that is called from the IE current, and 1, 2, 3 we are going for the emitter current. Okay, that is called emitter current. Corresponding it will be nodal for the collector base. Only you can change this value. Base voltage change பண்றீங்க, base collector current note பண்றீங்க. Okay, so finally you can note down this value. The ரெண்டு vary பண்ணும்போது collector base voltage vary ஆகும்போது always vary from the collector current also. In this vary, this is only constant. What is the constant voltage? I is equal 0, I is equal 1A, I is equal 2A, this is 1. Okay, so this is called as output can be vary, correspond node for the input. What is the input side? We can note from the IE equal to input of this side. Okay, so there are two configurations. First one is common base configuration. It can be available through three current. It can be calculated. First one is IB current, and second, first one is you can IC current. Then it will be go for IE. IE is equal IB plus IC. Whatever it is, IE is equal IB plus IC, and third is called from the IB current. Okay, this is the first parameters you can calculate. Next one is input as well as output. What is in the input characteristics? Input characteristics only it can vary the input side. Output side is a corresponding constant. It can be changed constantly. You can take down. That is called for the input characteristic. And output characteristics, output should be vary and correspond node for the input side. What is the input side? That is called from the IE value. This is the first configuration of that is called from the common base configurations. Okay, so what is the output of there are three regions available. First one is already told that active region, cutoff region, and saturation. What is the active region? This is active region. This is cutoff region, and this is from the active region. Okay, this is totally. This is also saturation. Everything it will be saturation. This is also saturation region, and this is one is active region. This is very, very important. Active region is very important. Active region, cutoff region, and saturation region. Saturation region is negative to come to positive value. So negative 2. This is also constant. Whatever it is, this is active region. This is also leakage. That is called ICBO. Already, what is in the ICBO? ICBO is nothing but some leakage current will be available. So that will be negligible. Only it can take from the original value. It can be taken. That is called for the IP value. Okay. So saturation region available. Active region is available. This is also cutoff region. So this is the definition. What is it? The active region. The active region is nothing but the emitter base junction is forward bias, or the collector base junction is reverse bias. Already told that this condition can satisfy. That answer will be operator. Then collector current IC is approximately, the IC current is approximately is equal to the emitter current IE. Almost IC is equal, IE almost equivalent, and works as amplifier. In active region, it's a standard formula. I is equal IE is equal IC. It's a standard. Or whatever it is, IE is equal IC. Approximately it will be. Next, go for active region. The collector current essentially is almost constant. In active region, the collector current is normally it will be constant value. What is the output resistance? Dynamic output resistance is ratio of changing by the collector base voltage and resulting the collector change. Formula not is del CB del IC. Next goes to for saturation region. What is the saturation region? In this region, the emitter base junction, J is collector base junction, J is both forward bias and VC has to be negative. IC, IE, these are the conditions. What is the condition? IE of the IE decrease as region, the collector current is nearly zero. This is a formula of it. These are something very important. Okay, what is the active region? What is saturation region? The third one is the traffic. These are very important characteristics of the first one. Okay, first of all, generally you can write out short explain in common base configuration. You can the diagram is very important. Diagram. What is diagram? You can write out that this diagram is very important. So diagram is a common base. This is very important. Whatever is NPN, we can current emit into the junction. That is called from the NPN, and PMP current enter into the junction. That is called from the PNP. So this is all the input of this side. This also output of this side. So this blue diagram is very important. And then we can write down or even explain that how leakage current IB is equal, ICU, or the leakage current will be like that. And finally goes to the characteristics very important. Input characteristics that is very important. Emitter base junction or scatter base voltage and emitter base current can use. And next goes to for collector. That is called for the output side. What is the output of the side? We can use for collector base voltage as well as collector current. Well, then we can mention what the cutoff region. What is this is a cutoff region? This is a saturation region. And finally, this one is this with this that is called for the active region. Okay, so this is the first configuration of common that will be used for common base configurations, and next it will be go for common emitter configuration. That is very important. Common emitter configuration. Okay, so second one is it will be go for common emitter configurations. Okay, so what is the emitter configuration? This is input of this side, and this one is output of this side. Okay, common emitter base junction is forward bias, and collector base junction is reverse bias. Whatever it is, any condition, emitter base junction is forward bias and collector base junction is reverse bias. So what is the condition? In this configuration, input is applied. Input is applied base emitter. Input is applied. This is also input of the base as well as emitter. So emitter should be negative. The positive should be connected to base. Okay. So that is called from the input of the output is collected from emitter current. This is called the output of the collector. It should be connected to positive. The emitter should be current. So normally it should be connected to normally the downside that is called from the ground or earth. Okay. Normally is called for common ground. Okay. Now ground illama that should not work anything at all. Electronics input voltage எப்படி யூஸ் பண்றீங்களோ பாசிட்டிவ் that is called from the voltage now ground it should be connected to common. Okay, so இது பண்ணாம இருந்தா that should not work anything at all. Whatever it is ground is properly should be connected into the ground. Okay, whatever is the polarity capacitor or whatever transistor diode and anything the ground has to be must. Okay, the ground short பண்ணீங்கனா தான் we can the circuit will be closed. Okay, so the ground நீங்க connect பண்ணல whatever anyone you can connect in that should not properly that should not work because the ground is very important. Okay, எப்படி வந்து voltage very important, the same thing it will be like that. Ground it should be very important. அப்பதான் வந்து closed circuit, the circuit will be closed now the current it will be passes, otherwise the current it will be leakage, otherwise it will become a short circuit. So the properly இருக்கணும் அப்படினா the voltage apply பண்ணுங்க same thing it will become for the ground also. Ground is a very essential thing of the electronic side. Okay, so first of all we can go for input is applied with the base emitter, output is taken from the collector. This is for the input, this one is output. Okay, whatever it is NPNP now we can use for PNP the current entering into the junction, this is the input side, this is the output side. Okay, whatever it is this one. And next point, it will be go for the emitter of this transistor. The emitter of this transistor common to both input. The emitter of the transistor common to both input, output circuit, the name of the common. Whatever the input side, that is called from the input, the output is the output of the integration. The common, whatever it is, NPN as well as from the PNP. The input voltage in the common emitter comes base emitter voltage. What is that? This is called the base emitter voltage. This is called the base emitter voltage, VBE. Another one is common VC. This is called the VC. This is VBE as well as the VC. Normally, whatever it is, anything, this is called VBE and this is also VC. Either whatever base emitter, collector, whatever this is, what base emitter, whatever it is, VBE is input, VC is output. What is the current amplification factor? Already you know the formula IC is equal alpha DC into IE into plus ICB. Last can derive from the IC value already derived from the common base. IC is equal alpha DC into IE plus ICBO. What is IC? You can convert IC minus alpha. You can come this change the polar, change the side. IC minus is alpha DCD. So IC divided by alpha DC. So divided by alpha DC. IC minus alpha DC. So divided by. So I alpha DC divided by both sides. Okay. So IE. So what is IE is equal? You know formula. I is equal IC plus IB. What is the already know the formula from the IC current? IC now IB plus IB. Okay. IE is equal IC plus IB. And next you go for the same thing, go for all IC divided alpha DC divided minus IC. So is equal IB plus, you can come for this side, come for this IC base alpha DC. And finally IC come for outside 1 minus alpha DC minus IC. You can simplification factor. So IC is equal IB into ICB, you come for this side alpha into DC. So what is this formula you can apply? Alpha DC into 1 minus alpha DC. So this is simplification factor. So beta is here, this is the stability factor. What is this beta? Beta DC is the ratio output of the current IC and the input of current IB, common emitter contributor. The common emitter contributor is current or gain. Or gain is mainly you can use for the current amplification factor. It will be very gain from the continuous. So next goes to for beta DC is equal IC. This is a formula. The beta formula on the IC plus, this is what is the IE is equal IB plus IC Mari. This is standard formula. Beta DC is equal IC divided by IB. So beta is equal IC divided by IB. So IE already IE formula IC plus IB. So IEB is equal IB minus IC. So beta is equal IC divided by IE minus IC. What is the IB? IB can calculate IE minus IC. So you can substitute the IB value, you can substitute, that is called IE minus IC. So what is the final value? So beta is equal, you can denominator equation by IE value, both divided by IE. So IC divided by IE divided by IC minus IE. So finally you can use for, you can consider by alpha. Alpha is equal IC by IE. That's the formula. Alpha is equal IC by IE. We can substitute the value alpha divided by 1 minus alpha. That is called as beta value. Okay. That is called as beta value. So already know the formula, alpha is equal IC by divided by IE is equal, everything you know the formula, substitute the value, alpha is equal, alpha divided, what is IE value, IB plus IC you can put it, and denominator you can put it for IB value. This one is IE, this one is IE. So finally it should be calculated from the alpha value. So in this value, you can go for beta as well as from the alpha. Alpha is equal IC divided by IB, IB divided by IB. Finally, go for beta divided by 1 plus beta. So what is the condition? Beta use பண்ணும்போது, what is the condition? Alpha divided by 1 minus alpha. Beta use பண்ணும்போது, so you can use to beta divided by 1. Okay. So beta use பண்ணும்போது, what is the value? Alpha divided by 1 minus alpha. Alpha use பண்ணும்போது, beta divided by 1 plus beta. Okay, that is to change the values, change the polarity. This is minus, this one is negative. Alpha, beta வந்து alpha use பண்ணுங்க, alpha beta. This is negative, this is positive. So beta வந்து alpha divided by 1 minus alpha and alpha is equal beta divided by 1 plus beta. This is the final value of current equation of IA current. Okay. So next goes to for characteristics of base curve. How to work from the base curve. So this is the same thing, base current as well as from the base emitter voltage. This is the input of the side. The same thing, whatever it is, anything, common base, common beta, common collector, whatever. This is base current as well as from the base emitter voltage. So the curve between the input of this side, that is called for the base emitter voltage, and input current base constant and collector current as a common value, it can be VC. The base current is to be taken. Okay. So the same current you note down from the where is the VC. Where is this is also input is what is the VB is input as well as from the base current. Can change from the base current change of the and note down from the VC. Okay, VC is a constant value, 20 volt and 5 volt. Okay, 5 volt set பண்ணுங்க, next 20 volt. 50, whatever ready volt you can fix, that value you can note the value. The corresponding increasing the value. Rapidly you can increase the value. That is standard. You can check that one. Normally it will be like that. The base not adhe mari dhaan irukum. Gradually you can. The same thing like that. Whatever it is, everything it will be same thing. It will go for the same value, same input. And next goes to for output characteristic. Output characteristic is same, it will like that. What is the output characteristic? The characteristics between collector current output side and collector voltage. Okay, the various field can be field IB. Okay, the collector current vary the current premium. The various field IB it will be IB it will known. Okay, so the characteristic output are the what is the collector base voltage? This also emitter base that is called the emitter collector voltage and collector current. Okay, noted for the that is called from the IB current. IB current வந்து input வந்து note பண்ண போறோம். The output vary பண்ணி input note பண்ண போறோம். அதான் மேன். So the same thing that is called what is the region? That is called from the cutoff region. This one what is the region? That is called from the saturation region. In this region that is called from the active region. Whatever the what anything what common base of no common whatever it is, the same thing it will be like that. So this also gradually you can adon sharp you can check that the diagram. You can check that diagram. This is a sharply you can break down. Sharply everything it will become for sharply you can break down. So idhula pathina you can check that common emitter. You can change the some the timing is very, that is saturation timing is very, this is positive side, this is a positive side, and this one is you have to compare for negative side. So more than you can check that this is negative side, only you can sharply you can zero it will be very, because that is the main thing. Common base la common collector la you can check that we can everything it will be go for positive, not from negative side. So this region that is called from the saturation region. Okay, so for everything it will become positive, not from negative voltage. The previous la common base la some negative voltage already know that ICVO is there. So negative voltage is there, negligible, that value is, so if this one is everything it will be taken, everything, not only losses, minimum level it will be losses. Adla pathina negative nariya losses irukum, but in this only can positive losses, that is called from the saturation region. In this region that is called from the active region. So that is called active region. So del IC can calculate, that is called del VC. That is the formula from the IC plus IB. Okay, so this is very important, that is called VC as well as from the collector current. This output outside, not on how the input on this side. Otherwise it's the same thing like that. This is very important. So this is why it is used for active region, why it is used for that is called active region and cutoff region, you can explain. And next goes to for finally it will go for common collector configurations. So this is very important from the common emitter la you can check that all the values, that is called beta value as well as from the alpha value, it should be very very important. Okay, adula pathina we can calculate by the IB IC IA calculate pannirpinga, that is called for the common common base configuration la. But now itself we can use for common emitter configuration, it can be used for alpha as well as from the beta. Beta is equal alpha divided by 1 minus alpha, negative value, that is called from 1 minus alpha, that is called from the beta. Beta is nothing but the stability factor of the transistor, and alpha is another one of these factor. Alpha is equal beta divided by 1 plus beta. So the same thing go for transistor graphics, very important. So base voltage, base emitter voltage, base current. Okay, base current measure பண்ண போறீங்க. And next goes to collector voltage la collector current. The base current, this is collector current. And third one, it will be go for common collector configurations. Okay, the common collector configuration, same thing. Okay, this is base emitter function is forward bias, the base collector function is reverse bias. Okay, what is the base function? The emitter should be connected to this one. Okay, the emitter should be connected, and this one we can vary this of the input of the side. Okay, the emitter want to go for outside, outside not from the input. Okay, so the input side, the emitter collector base junction is forward bias. Emitter base collector function is forward bias and base emitter function is reverse bias. Okay, idhula mattum dhaan change agum. Okay, emitter வந்து totally go for the collector normally output la dhaan irukum, but idhula pathina input agum. So the base collector junction is forward bias because we have to collector is dominant. Okay, because it can be dominant from the collector. So the collector is dominant, so the base collector is forward bias. That is called input of this side. The emitter collector, that's the constant. This is one output of only you can change by the collector. Okay, so this is the collector from the input of the side. This one output of the side. The same thing go for the current entering the junction. This is called the base is negative, factor is positive. That is called reverse bias. So this is the forward bias. Okay. So the whatever it is, anything it involves. The emitter base junction is forward bias. The collector base junction is reverse bias. Okay. So next one is what is the condition? The input applied by the base and collector. Okay, what is the input of the side? The input you can apply by the voltage, you can base as well as from the collector. This is all the input of the side. And output is it should be connected to collector. The output is should connected to emitter as well as from the collector. So VB is input of the side and VCC is nothing but output of the side. And second condition, the collector of the transistor of both the collector of the transistor of the collector of the common. The collector is the transistor common both input and both output of the circuit in the common. Collector of the common common collector is input common, then it will be output will common. Okay, the same thing whatever emitter base. And next goes to for third point. So this is the PNP transistor as well as from the existence. Okay, so whatever it is, this is the emitter. Normally the previous section emitter base junction is called emitter base input of this side. Whatever it is, base base configuration or the emitter configuration. The base common emitter is input and common collector is output. And this one is base collector is input. Base collector is input and collector emitter is output. Collector output is common. Whatever the output is common, but the input won't change out the emitter base junction. So emitter will be. So what is the formula? You know that IE is equal IB plus IC. At the end of remaining IB is equal IB plus IC. And IC value already negligible value alpha DC IE plus ICB. The formula you can once again every markup. Okay, what is IB? Where it is come for IE now, that is called IB plus IE current now, IB current as well as from the IC current. Adhe mari IC current now, alpha DC IE plus ICB. IC current definitely leakage current it will be there. So negligible current will be there. So that is called from the alpha DC IE plus ICBO. This is a standard formula. So then we have to substitute the value from the come this side. IE minus 1 by IB plus ICBO. IE is equal 1 divided by alpha divided by substitute the value. So we need the value. Already can calculate for the beta value. Beta value is equal alpha divided by 1 minus alpha. The previously you can calculate by the emitter. Emitter value already calculated. Beta is equal alpha divided by 1 minus alpha. That is called stability factor. So we can add it by 1 plus stability. We can 1 plus stability means the stock could can be once again you can extend. That is called from the 1 plus beta DC. So 1 plus alpha DC divided by 1 minus alpha DC you can add it. So 1 minus alpha, you can remaining rearrange the equations and finally go for 1 minus 1 divided by 1 minus alpha DC. You can cancel this one. So 1 divided by alpha DC. Okay. So this one is cancel. Alpha DC plus alpha cancel. 1 divided by 1 minus alpha DC. Finally, you can substitute the value, IE value. IE is equal IB plus IC. IB is nothing but equal 1 plus beta DC and ICB 1 plus beta DC. So negligible, ICB negligible. So IB into 1 plus beta DC. Okay, so finally this is value from the IE current. IE is equal IB plus IC in the okay, you can change IE is equal IB into 1 plus beta DCR. So finally goes to for current amplification. Gamma is equal IE is equal IB. This is standard formula 1 plus beta DC. And finally you can substitute the value 1 divided by 1 minus alpha DC. That is called from the current amplification factor of the collector configurations. Okay, well, collector configuration, what is the value? 1 divided by 1 minus alpha DC. That is called from the collector configuration. So first configuration, we can check the common base configurations. And second one, you can calculate IE, IB, IC can calculate. The second, you can calculate by the beta as well as from the alpha. That is called from the common emitter configuration. And third one, it can be used from the gamma value. That is called from the common collector configuration. That is called from the 1 divided by 1 minus alpha DC. That is called from the and next goes to for input of the characteristics. What is the input of the characteristics? Already know that input of the characteristics of common collector as well as from the common base. Okay, input of the common use பண்ணிருப்பீங்க, base use பண்ணிருப்பீங்க, collector use பண்ணிருப்பீங்க. Okay, well, you can check the diagram. Base as well as from the collector, not from the base as well as the emitter. It can use for base as well as from the collector also. What is the thing? Okay, so the base as well as with the collector. What is the condition? The input characteristics of common configuration. The graph is input of the current IB versus output of VCB voltage and constant and VC. The output it will be constant. Output it will be constant. Okay, output will be constant. So what is the input of this side? So this is not from the gradually. So suddenly it can increase, not from the suddenly the collector current suddenly it can increases. That is called from the common collector configuration. And previously, gradually it can increases and gradually then it will become for this one and this will become for this one. But in the sharply you can take down. That is called from the common collector current. Okay, common collector on the you can check the common CB as well as from the IB. You noted from the VC value. Okay. And that is called from the family. So VC is equal, this is standard formula, VC is equal VCB minus VBE. So VCB is equal VCE plus VBE. This is standard value of the input of the characteristics. So input of the characteristics, you can sharply, you can vary. Okay, the base current you can note down. So VC as well as from the IB. So you can note it from the VC. VC the not output the not. So this is input common base vary pandringa, common current vary avudhu, correspond note for the VC. Okay, so that will be noted on the values. And next goes to for common collector. The common collector, same thing, it will go for common emitter configuration, not from negative side, only it can go for positive side voltage. So everything is the same thing value. This was the cutoff region, this one is saturation region, in this region that is called from the active region. The same thing like base the connect. This is you can go to the output of the side. You can go to. So what is the input of the side? VCE as well as this output of the side, VCE as well as from the collector current. Okay. So note on the input of the side. That is called IB should be noted. Okay. Collector current output side you can vary the from the output of the side. That is called VCE as well as from the collector current correspond node number the input of the side. Input is nothing but IB value. So shortly you can go for 0 micron. This is microns, not from milliamp. The previous you can chapter, the collector we can use to for. So this 0, 20, 40, 60, 80 is there. And this one is you can use to for the same thing like that, but minutely it can vary. So minutely it can vary from the this is current. So this is Delhi. So everything it will be same. Almost it will be same. So minute will be changed from the micrographs current. That is called from the common collector configuration of output of the characteristics. Almost it will be equal from the common emitter as well as from the common collector. Anyway, equal that should not vary at all. But emitter, so I gain it will be available. Gain is more than gain, it will be available from the collector. And next goes to for comparison is very important. What is the comparison? That should be very important from the common base, common emitter, and common collector. And first of all, you can check for input resistance. Input resistance normally common base very low. That is all from the 20 only you can use for 20 ohms level. Okay, and the common emitter it will go for comparatively for 1 kilo ohms it will available, and this is called the configuration used for 500 kilo ohms. And output impedance, the output resistance very high, that is called 1 meg ohms, and this is from the 40 kilo ohms, and low, this is very low, because we have to doping level, it will be changed. Okay, doping level change பண்ணும்போது everything it will be range, it will be changed. Okay, this is input level, this is very low, very high, and next one is very high, opposite we can use. And next one is input current, this is IE, this is IE, this is IB, this is IB. Input current you can, this is IE can you can note down, both collector configuration and the IB. And this one output current IC should be IC and IB. Okay, and output current it will be changed. And next one is input voltage between emitter base and base emitter and base collector. Okay, input connect this is emitter base and base emitter and base and collector. And leakage current on the very small level from the common base and common level this is very high. And next goes to for output voltage between. Okay, that is for collector base and collector base. Okay. Then you have the amplification factor. Alpha is equal IC divided by IE. Alpha is beta is equal IC divided by gamma is equal. This is alpha, beta, gamma. Alpha is equal IC divided by E, IC by V, IE by. This is a formula from the current amplification factor. And next goes to for current K. This is less than from the unity of the level. And next one is it will go for I level. And the same, almost it will be equal from the this one and this one is equal. And voltage is a medium as medium, is less than from unity. What is the application? So this is called as multi-stage amplifier or frequency of application can be used. And this is one you can divide this for signal amplification. The provided it can be both current and greater than unity. So widely used for audio signal amplification. This is very important. The common emitter now we can be amplifier circuit use பண்ணுவாங்க. And finally goes to the impedance matching. Impedance matching. What is the impedance matching? Everyone used the balloon. What is a balloon? The TV side outside we can one connector is there. TV நீங்க பாத்தீங்க அப்படினா whatever any TV CRT TV or whatever it is, anything is the oldest TV can use for balloon is there. The balloon you can connect it to that positive as well as negative. It should be very So it should be matching network. So the antenna particular frequency it can be taken. Other frequency that shouldn't be taken. That is called from the matching. That is called impedance. Impedance now you can transform it can be used. Impedance now it can be used from the transform it can be used. The transform that is called from the coil it can be used. The coil can be produced EMF it can be used. That is called the particular EMF that should be other frequency that should be. That is called from the impedance matching of the circuit. Okay. The balloon, mainly it can be used for balloon circuit. It can be used for antenna side, then it will be used from the transmitter side as well as the receiver side. Both it will be used for balloons. That is called from the impedance matching circuit. You know that from that CRO, everyone know that CRO, that is called cathode ray oscilloscope, used from the laboratory purpose. It can be used. You can measuring from voltage or current. So devices. So suppose we have to connect it into that CRO, it should be connected into that output of the level. Okay, CRO probe la connect பண்ணிருப்பாங்க. The output should be connected positive negative is the probe la connect பண்ணிட்டு the impedance matching. Okay, the balloon the impedance matching சரியா இல்ல, that should not matching now. The everything it will the value it will be vary. Okay, that is very important. Impedance matching la wherever it is it will be connected into that CRO, TV and whatever it is, and the spectrum analyzer and that is called wave analyzer, antenna analyzer, whatever it is, anything it can be used for the propagation of matching of network is very important. That is the particular frequency it can be taken, other frequency it will be, that should not be allowed. This is called from the impedance matching of the circuit. These are from this the common collector la use பண்றாங்க. Common base, common emitter can be used for audio amplifier. That is very important. Okay va, நீங்க where it is used for theater, cinema theater and conference and where it is used for everyone used for amplifier circuit it can be used. One it will be used for mic it can be used. So whatever it is output of the factor, what is output of the factor? It will be speaker is there, input of the factor mic is there, output of the factor it will be connected to the mic. That is in between that is called amplifier. Both it will be controlled, speaker as well as for the mic it will be controlled. So that will be the noise that should be reduced. That noise it will be reduced. The original noise it will be original signal should be taken. That is called from the common emitter amplifier. Common emitter amplifier, the high gain it will be produced comparative for common base as well as for the common. This input stage இது வந்து normally multi-stage amplifier. Multi-stage amplifier you can use for a communication circuit. You can use for there are multi-stage amplifier circuit can be used from the FM modulation circuit can be used. Suppose you AM modulation, FM modulation. Now you can multi-stage amplifier circuit. Class A, Class B, Cushbull, and there are different amplifier circuit. That is called multi-stage amplifier circuit. From the communication circuit can be used. And second one, common emitter, normally it can be used for amplifier circuit. Normally it can cinema theater and whatever it is, it can be used from the that one we can use. And common collector, impedance matching, that is called antenna circuit. So these are from the very important topic from the second unit. The second unit, enter the second unit, it will be due for only for transistor configurations. Okay, so configuration is very, very important. How it will be calculated from the input side as well as from the output side. Input side now you can calculate from the input of the characteristic, and output of the side it can be calculated by the output of the characteristics. Okay, so finally it can be calculated by the various levels. It can be go for alpha and beta and the gamma. It should be calculated. Okay, the current mainly it should be calculated from the current. It should be calculated very important. That is called it can be used from the BJT is nothing but current control devices. Okay, what is the difference between the FET and BJT? Now BJT can be used from the current control devices. It can be act by the switching circuit. Okay, normally it can be BJT is nothing but is act as a switch. The current control devices and bipolar junction transistor. There are two junctions available. First one is common emitter base junction and collector base junction. There are two functions available. Two depletion region is available. The potential barriers should be very good. These are from the several advantage from the transistor. Okay, nowadays everyone moves together from the IC manufacturing chip. not only for transistor manufacturing. Everyone moves together. IC chip, that is called for integration chip. Okay, so integrated chip, there are several types of chips are available: LSB and MSB and VLSI. LSI circuit, MSI, that is called log scale integration, medium scale integration, very log scale integration, and ultra log scale integration. There are several advantages. Each and every amplifier, every circuit, it can be used from the CMOS transistor, not only ordinary. This is one ordinary transistor, emitter base junction, and CMOS transistor, that is called from the gate, that is called gate and silicon control is very good. So these are we will discuss about the 7th semester how to work for the CMOS gates. Okay, so NMOS gates as well as the CMOS gates is available. The gate that will be used for field effect gate is advanced from the CMOS gate also. So these are from the several advantages from the transistor. Now we still everyone moves to the FinFET technology. FinFET is now everyone is nanometers. Okay, very low level manufacturing side is there. So it will be a lot of advantages. So okay, the single mobile there are several applications it will be included. Okay, single ICs there are 10 lakhs transistor, not only for single transistor, 10 lakh transistor inbuilt in a ICs also. So there is several advantages. There are several applications it can be used. So whatever it is, the camera and the storage and analyzing, whatever, there are several sensors. Everyone moves to the sensor world. So a lot of sensor it can be used in the single chip also. We will study in the 7th semester. Okay, these are from the several advantages from the transistor. These are several advantages of transistor evolution. Evolution of transistor is very important. Every transistor, then it will go for LSI circuit, MSI circuit, then it will go for VLSI, ultra scale, and FinFET technology. And these are from the evolution of the transistor also. Transistor based on that, we can develop in the technology also. So these are from the very important topic of configuration. The first topic, how to work on the NPN transistor, how to construct a working principle, last class, video class, NPN transistor as well as PNP transistor. That's very important question. Today I have to discuss the configuration. Definitely one configuration will become for the semester exam. Okay, the moon configuration, definitely it will be one configuration will become for the final exam. So especially it will go for common emitter configuration. Is very important because the stability and the current amplification factor, input impedance, whatever it is, everything it will be good from the common emitter configuration. So in the questions, definitely it will become for whatever it is, final exam in the question, the tab 2 and whatever it is, anything it will become for this type of question will be asked. 3 configuration, definitely any one configuration. Very simple factor. Okay, just we have to change the position. That's all. Common emitter base. Emitter base calculate. Other base money you can change it the polarity. That's all. Common emitter forward bias junction and collector bias junction. The base money correct then it will be calculated by the formula alpha, beta, gamma. It will be calculated, and finally it can be characteristics. It will be input characteristics as well as output characteristics. Input characteristics just we have to input. It can vary correspond order for the output. That is called input characteristics. Output characteristics. The output it can be vary correspond order for the input. That's all. For all the characteristics, input are on a common base and common emitter, whatever it is. And the comparison, comparison is very important. Okay, whatever it is, it will be go for competitive exam, it will be go for interview side. Just you have to simply what is the current amplification factor, defined current, what is the application for common emitter, what is the leakage current, what is why it is used for input resistance, why it is used for output. These are from the several questions or it will be asked from the interview side. Okay, so gate exam one competitive exam and what a government competitive and whatever it is in this transistor, definitely it will be asked question. What is IE formula? IE is equal to IB plus IC. What is IC formula? These are what is IC? This is simple. So IC is nothing but it's leakage current. Okay, the ICB is definitely with that. So leakage can beta DC plus IC. These are from the several things we can study. The last configuration is very important comparative for last 3. Common emitter, common base, and common. On the base, a lot of question is there. Will be there. Okay, so these are very important things. So now it will be go for how to work from that simulations. That is very important. Okay, the simulation part is very important. This is our subject. Both it will be added. Okay, both it means theoretical as well as from the practical. Okay, that's specialty. Okay, that is called ETL. ETL is embedded theory of lab. Embedded theory of lab. That is called ETL. ETL is embedded theory of lab. Can convert into that. What is embedded? Embedded is nothing but both combined in together anywhere, software or hardware, but in this theory as well as okay. What is embedded system? Very big topic from the electronic side. What is embedded system? Embedded system is both. It will be combined. What is both? It will be combined both software as well as from the hardware. It will be that is called from the, what is the embedded example? It will be used for mobile phone. Mobile phone la pathi rendu me irukku. It can be used for hardware irukku. It will be used for the software. Both it will be combined together and human value. Human la pathina we can brain as well as in the heart. Heart is a hardware, brain is a software. Both it will be combined. Human la very good embedded system. The world, all over world la very who is the best embedded system? No, who is our body system? No. Heart is a hardware system. Brain is a software. Both it will be like that. The same thing it will be go for mobile phone. Mobile phone hardware irukku, it will be combined with software. So that is called the same thing. It will be called embedded theory as well as the practical also. Okay. So now we can go for practical session. So next goes to for common emitter characteristics. Ella theriyada ba? Everyone have to see that?
Yes, sir.
Okay. See that emitter common emitter characteristics. So these are from the everything is available. You go and check that virtual labs. So a lot of application it can be used. Suppose we have to use a theoretical part. Okay, this is everything is available for theoretical part. What is a PNP transistor? What is NPN transistor? And what is the different CATs, different active mode and cutoff region, saturation region and active region. It will be like that. Everything is available. What is the forward rate of ICU, IBU, and everything is available from the theoretical part is available. And input characteristics as well as from the output characteristics, everything will be calculated. Okay, these are from the theoretical part. And next goes to our simulation part. You can go for BJT input and characteristics. Okay, so input characteristics la we can check that this is of the basic circuit of the common emitter configurations. Common emitter. This is of the transistor. This one is transistor. So this is of the base. Everything it will be controlled to the base side. And emitter should be for ground. And this one is for the collector. Okay. So what is the condition? Input characteristic only you can change the vary the input of the set. You can vary and correspond node for the VCB you can note. Okay. This note panna poringa. Okay, இது vary பண்ணி இத measure பண்ண போறீங்க. அதே மாதிரி output characteristic this one is with vary correspond one for this one. Okay. So what is the components? So transistor is very important. DC 107 it can be used. The emitter should be from the ground. The base should be connected to supply. The collector should be connected to another supply. Okay, ரெண்டு supply use பண்ணனும் VB as well as from the DC. Okay, and then next goes to for current. What is the different current? IB current is there, IC current. Okay, IE current is everything will be ground. Okay, everything will be ground. So you can measuring for IB current as well as from the IC current and measuring the voltage VB as well as from the VC. So how many equipments are there? Transistor is there, and next goes to for two supply. One supply, another two supply is there. One transistor is there, and meter, two current meter, IB meter as well as from the IC meter, two voltage meter, VBE as well as from the VCE, and then vary the rheostat. Rheostat is nothing but you can vary the voltage level. So vary the resistance. The rheostat is nothing but the copper wire. It will be the wounded wire is there. The wounded wire is there. Then it will be. That is called rheostat. Rheostat pathirikku nenikkira. Something not about see that. Something not see that. Rheostat is nothing but it's a coiling is there that can be vary. That can be vary to movement to forward as well as the reverse direction vary. That is called from the rheostat. Okay. Potentiometer is different. There are two types of resistors available. First one is fixed resistor, another one is variable resistor. Fixed resistor, whatever it can be used, it can be used for carbon resistor. Carbon resistor, it can be used for color coding. Okay, carbon resistor, it can be used for color coding. B.B.R, great bit and very good boy we can use. There are three band is there. The first band is direct value, the second band is direct value, and third value should be added to that zeros. Suppose you have black, red. What is black? Black is black is 0. Brown, black, red. Brown, black, red. What is brown? 1. Black is 0. And red is 0, 0. So 3 0 is added. That is called 1K. Okay. Suppose we have the first 3 rings. What is the first ring? That is called brown. What is the brown value? 1. Black is 0. And red is considered red. You can add about 2. 2 zeros also. 1K. So what is the fourth ring? That is called from the tolerance. Tolerance is the manufacturing. It can be provided. But if suppose we are 10%, exactly that should not be calculated. Okay, exactly panna mudiyadhu. But the manufacturing defect is definitely will be there from the whatever any manufacturing system, electrical, electronics, mechanical, whatever anything, some tolerance definitely will be given there. So that is called from 10%. 5 or 10%, 20% will be available. Okay, so these are from the tolerance. It depends upon the you can manage. Suppose 20% now, you can 1K, 20% you can check it. 982 you can use to for 1020 tolerance is okay. 10% now 992 110. So these are from the percentage of tolerance. Then the normally you can 4 band of ring is available. That is called from the carbon ring. That is called fixed resistor. Variable resistor. There are 2 types of there. First one is you can use to for rheostat. Another one is potentiometer. Potentiometer is you can vary the. If you TV directly it can be vary the frequency. TV radio you can use from check you can notate the that vary the frequency. That frequency that is called from the potentiometer. Potentiometer input, ground as well as output. Input, output as well as. So you can change the whatever you can change. The rheostat that is totally different. So totally you can change everything. It will be coil will be there. So that coil it can vary. So the different types of frequency, different types of resistance it will be calculated. That is called the rheostat. Okay. So rheostat enga connect பண்ணிருக்காங்கன்னா you can check the base la connect பண்ணிருக்காங்க. That is called base. It should be connected to input side and collector should be connected to another rheostat. So through rheostat it will be connected. RH1 that is RH2. RH2 is nothing but output of the control. This okay. So next goes to for so how to calculate. So this is the input of the voltage VBB and this is VCC output and 2 current meter that is called IB as well as in the IC and input of the set is base emitter voltage and collector voltage. Okay. So first we can change the value. What is the procedure? Go to the instruction. So initially rheostat 1 comb and both it will be 1. So rheostat on the both it will be 1. Rheostat 1 you can put it for 1, changing the value. You put it for 1. And rheostat, this is the input of the side. Rheostat 2, this one is you can change the from the 1. Okay. Both it will be 1. Okay, the first condition. And second condition, set the collector emitter voltage. Collector emitter voltage 1 volt adjusting by rheostat 2. Okay. So rheostat vary பண்ணி VCE ல வந்து this is VCE ல வந்து 1 volt வைக்க சொல்றாங்க. VCE ல 1 volt rheostat vary பண்ணி VCE is equal 1 volt. Okay va? This is 1. This is 2 na, this is 1 volt. This is 1 volt is there. Okay, 1 volt is there. Adjusting by rheostat VCE set பண்ணிட்டீங்க. VCE ல வந்து 1 volt set பண்ணிருக்கீங்க. And then VBE adjusting by the base emitter voltage. Base emitter voltage adjust பண்ண சொல்றாங்க. Adjusting by R1. R1 adjust பண்ணி base emitter voltage. Okay va? Vary ஆகும். You can vary the voltage. Okay va? Vary ஆகும். So what is the voltage? Adjusting from the VBE and corresponding note down the reading IB current. What is IB current? So in the current note பண்ண சொல்றாங்க. So in the current note. What is the plot? This is the table. So what is the value? You can check that. Base emitter voltage 2 volts set 0.2 set பண்ணிருக்கீங்க. What is the base current? That is called from the 2 point. This is 10 now. This is 10, 20, 30. So 2. This is everything 0.2. So 2.18 is there. Okay va? First of all, note on the this value. Input the note பண்ண போறீங்க. ஓகேங்களா? So base emitter voltage 0.2 base emitter input தான் note பண்ண போறீங்க. ஓகேவா? அவுட்புட் வந்து கான்ஸ்டன்ட் வச்சு ரீட் பண்ண போறீங்க. Next goes to for note down the plot. Next go note the reading from base current IB ampere and click the IV characteristics common in the graph on the VB as well as click on the 2 volt and 3 volt. Next goes to for next vary the level. Rheostat it can vary. Rheostat 1 should vary. Okay. So what is the value at the table? Okay. So next goes to vary the value at the table, and next vary the table at the value. So next goes to our plot the graph. How to the graph? So gradually you can increase. Gradually you can increase. So normally you can go for this one. So the பண்ண முடியனால you can இது பண்ணிருக்கோம். Okay. So what is the value? You can gradually you can increase the value. In this point you can increase the value. Okay, that is called from the common base character also. Okay, so this is a gradually you can increase. The first point, 0.25, 0.4, 0.5, and 0.8 approximately you can go for this level. Okay, so this is called from the 10 level you can increase. This is 10. This is out of 5, 4 this is approximately for 8, and this is 4, and this is for 3 by. Okay, these are from the gradually that is called from the common base configurations, common emitter, common as well as emitter. So this is the plot of the graph. Okay, this is very important. So next go to change the values of the resistance value you can change. Next what is the procedure? Next go to for 2 volt. We see go for 2 volt set பண்ண சொல்றாங்க. Next goes first வந்து 1 volt set பண்ணோம் இல்லையா? Next goes to for 2 volt you can set. Next you can go for 2 volt adjusting for rheostat. Okay வா? எல்லாம் clear பண்ணிடுங்க. Clear பண்ணிட்டு next goes to first you can initially you can set up 1 volt and rheostat vary பண்ணி we can go for 2 volt. 2 volt set பண்ணீங்க. Next 2 volt you can set. Okay, 2 volt set பண்றீங்க. Next go for vary the 2 volt and next go 4 volt whatever it is. 4 volt கூட set பண்ணிடலாம். 4 volt set பண்ணிடுங்க. Next go for vary the voltage. What is the vary the voltage? You can note down the values. So for add the table, first value and second value and third value and fourth value and fifth value and sixth value, whatever it is, you can put it. Okay, so next go for plant. Okay, gradually cut. Okay, so that is called from that. நீங்க என்ன பண்ணணும் அப்படின்னா what is the needing? Input vary, output should be constant. Outputல வந்து ஒரு வேல்யூ வந்து செட் பண்ணிடுறீங்க. That is called from the output value you can put it for this voltage. Corresponding change for the input. That is called from the input characteristics of common emitter configuration. Okay, this very thing. Okay, only you can input is vary, correspond node for the only you can fix பண்ணிக்கிறீங்க. That will be whatever you can choose one 3 volt. Okay. So these are from the common base configurations. Okay, and the same thing, whatever it is. Any doubt from your side? Doubt irukappa? Hello. Doubt
Sir, attendance.
Mohammed Ashik, tell me, ma.
Yes, attendance, sir. Completed. No, I'm asking about attendance, sir.
Attendance.
Yes, yes.
I will take no problem.
Okay, okay.
Any doubt from your side from
No,
the subject?
no. No, sir. Actually, I have one doubt. When I'm class joining now online, in Google exam, Google Classmate, there is a what link anything not finding like that problem.
Okay, then it will be discussed about later. No problem.
Okay,
Today I have to discuss one day content. Today I have to discuss about that.
Thanks.
This experiment I doubt. Any doubt from the experiment side?
Sir, both values are RH1 and RH2 same values means how can we get graphs?
Vishnu sir, so tell me, ma, what's the
Both
problem?
RH1 and RH2 are same values. If we get same values, then how will we get graphs?
Not from the same value. You can check that value. You can input. You can set. Okay, RH2 is nothing but you can control by output of the state. RH2 is nothing but control output of the state. Input you can vary. Okay, once we have to set up, then you have to leave it. Okay, once we have to set up from the output, then you have to leave it. Only you can change from the input of the side. Okay, wow. That's a procedure. That is called input characteristics. Suppose output characteristics now, input you can set, only you can change output value, R2 it will vary. Output la vandu pathina, this is you can set the input, only you can vary the output. That is the main difference between input as well as with the output. Okay.
Yes, sir.
Okay. Okay. So next, so first you have to give the attendance, then you have to discuss it.